So, hello everyone who's come. This is Into the Unixverse. So this is a workshop we're going to talk about all about Unix. So we're going to talk about what it is, why we use it, and most of this talk is going to be how to use it. So I think that I will talk about some admin stuff first. So the easiest way to follow along with the practical parts of this workshop, so when I switch over to my terminal like this, this will be the practical part. So if you want to follow along, if you want to try the commands, which I'm going to show off on your own computer, the easiest way to do that is just to open up VLab and open up a terminal. If you don't want to use VLab and you want to follow along on your own computer, I'm unfortunately not going to be walking through how you do that. I assume that if that's something you want to do, you have it all set up. So if you're on Windows, you have something like WSL already set up. But yeah, if you don't have anything like that, just VLab is fine. If you are following along on your own computer and you do have all of that set up and you know a little bit about what I'm going to be talking about, the shell that I'm going to be using to demonstrate everything in this talk is bash. So if you don't know what this means, if you don't know what bash is right now, don't worry, we'll get into it. That'll be coming in a couple of minutes. But if you do want to play around on your own computer and you want to make sure that everything works as it will in this talk, use the bash shell. I guess we'll talk about some goals for the talk. So if you're a 1511 student, then what you should be getting out of this talk is a little more detail into the terminal that you might have seen in your labs. So I presume that they show off still a couple of like commands for changing around directories and looking at files, but that's all very basic stuff. So we're going to look a little bit more detail at all of that stuff. So you should walk away with a decent set of knowledge with the shell. If you're someone who's coming in from something like Comp 2041 and you've already done 1511, then a lot of the material that I'm going to cover in this talk is going to be familiar, but this should sort of be treated as a gentle recap of all of the stuff you might have covered in the first 2 weeks. Although everything we do cover today won't cover everything you do in 2041. So only revision of some parts, but you might still learn something. I hope that if someone here has some knowledge about Unix already, then I show them something that they didn't already know. So hopefully everyone here walks away with something today. After I've finished each command, I'll probably pause and wait for questions. So if I'm looking off to the side, I'm looking at questions. I'll also give a verbal prompt. Feel free to use your mic if you want to ask a question, although probably to avoid the case of more than one person speaking at the same time, what I'll probably do is I'll repeat the question I look at in chat. And if that's your question and I finished answering it and you want to know more, you can speak up. But try not to speak over each other. And obviously when I'm doing something like going through a command, that's probably best if you don't use your microphone then, but you can still ask questions in the chat. As I said earlier to those of the people who were here before I started the recording, all of the commands I use today, I'm going to have in a sheet, a file. This hasn't been made available yet, so the slides are in the chat. But this is another supplemental resource. If you fill in the experience form, the feedback form at the end, you'll get it for submitting that form. So that's an incentive to do the form. Please do it. We love to know how we can improve these things, but there is a reward for that, and that's that feedback form. So I think that's all of the admin stuff I had to talk about. So I'll ask if anyone has any lingering questions at the moment before we actually get into the content. Okay, I don't think anyone has questions, but I didn't expect anyone to have them at the moment. So we'll get into the actual talk then. And we'll start with a brief history of Unix. So obviously, if we want to know about this Unix thing, we should know where it comes from and what it is. So Unix is a family of operating systems. Note, a family of operating systems, not an operating system. And it was developed from 1969 onwards at Bell Labs. Now, if you're a computer science student, you've ever written some C or anything like that, this Bell Labs place is really quite important because that's where the C programming language was actually invented. And it's also where Unix was invented. So quite a lot of useful stuff came out of there during that time period. Definitely a very important place in computing history. Unix itself is actually a C program. So all of the Unix code was originally written in something called assembly, but then they wrote it in C. And I'm sure everyone here is at least somewhat familiar with C, if not, an expert after doing it, and you're maybe in 2041. But you can just imagine that it's a C program. It's quite a lot more complex than the C programs you've probably written so far, but it is still a C program. And this was really quite special at the time because it meant that Unix was something called portable. So what used to happen back in the day was there were operating systems before Unix, obviously. It's not the first operating system. But how it usually worked was you'd have a computer and an operating system would be developed for your specific model of computer. So back in the day, those were like those huge box looking things, right? But you could imagine nowadays it'd be like having an operating system that only works or is designed for your specific model of laptop. But even if you have another laptop by the same brand, it's not guaranteed to work because it's written specifically for that machine. But Unix was quite different. It took a different approach. It was written completely in C, which meant that if a computer supported C, then it could run Unix, which is why we say it's portable, because we can run it on more than one thing. And this was quite special, and this was really uncommon. It was widely considered to be the first of its kind in this regard. So while Unix is quite old and it was developed like 50 years ago now, it still lives on today. So if you've ever used Linux or you've ever used Mac OS, that's based on Unix. So you owe a lot of the modern operating systems we have today to the Unix development back then, with the notable exception of Windows. So I haven't listed Windows here. That's because Windows uses something different. So because these old photos of back in the day are awesome, these are the kind of computers they were working with back then. And like I said before, you can imagine that before Unix, you had an operating system that ran on each of those boxes, but it may not necessarily, that same operating system may not run on the other machines necessarily. And the people in this photo are Dennis Ritchie, who you may know as the creator of C, that thing you do in Comp 1511, and Ken Thompson, who also did quite a lot of good work on Unix at Bell Labs. And this is them using those old computers. So I think probably the most important part of Unix, the most revolutionary part, aside from things like it being portable, was this thing called the Unix philosophy. So there's these three main principles that Unix seeks to abide by. And Peter H. Salas, this person here, put it best. I think this is the best sort of summary I could find. So the first of these is that you should write programs that do one thing and do them well. So what this is saying is that Unix strives to have programs available that are an expert at one thing and not some sort of jack of all trades but master of none, right? Obviously, this is better. It's better to have something that's fit for one purpose and does that flawlessly than something that does a whole bunch of things but isn't really perfect at any one of them. Second one, which I guess is probably the most complex out of these three, even though it's the shortest, is that we should write programs to work together. So we'll talk about what this whole notion of working together means later on. But you can imagine that given all of these programs that are really simple, they're all of these experts, like we said earlier, we should be able to combine these programs to build more complicated programs without having to write something from scratch. So inevitably, we're still going to have to write something. Like we have to figure out how we put all of these puzzle pieces together. But the point is we don't have to struggle through writing it completely from scratch. We can use what we're given and we can use these programs, they can work together and they can build this more complex functionality. So like I said, we'll see what this means later on at the tail end of this talk. But for now, that's a high-level understanding. And the last one is that programs should handle text streams, because that is a universal interface. So what we mean by text streams are just characters, streams of characters. So if you've ever given input to a program, say in C or something, I assume it's week 3, so we might be up to user input in Comp 1511 now. If you've ever given input, you're just giving a program some characters. So that's a really universal interface, because everything like files and programs, they're all just characters. Like a program might be a sequence of characters that we ascribe some special meaning to. Like we might say that this is a C program, or this is a JavaScript program or something, but they're ultimately just text. So if we can write programs that operate on text, we've got a universal interface, and we can't just use it for a C program and we have to use some different tool for a JavaScript one. So all of these Unix programs should ideally just take in text, process it, and that's how they work. So yeah, these 3 principles are really what makes Unix special, and what hopefully we should see today. So when we're looking at these commands, we should hopefully see all of these principles, this philosophy shine through. So I think that's it for history, but before we get into the basics, I'll ask if there's any questions. All right, I don't think there's any questions, so we'll move on to Unix Basics. So now we've had a little bit of a history lesson, let's talk about what are the basic things that make up Unix. So we'll start with the shell. The shell is probably the most important part of Unix from a new programmer's perspective. So the shell is just a program like the ones you write in Comp 1511, and it acts as the user's interface to the system. So it's something that allows us to interact with it, and it can get the system to do something for us. And the inputs to this program are commands. So you might have seen commands before, something like ls. We'll get into all of this in due time, but I assume that probably all of you have seen something like ls before. That's an example of a command. And the shell will take this command, and then it'll do something. It'll do what we want ls to do, basically. So yeah, we use this to tell the computer to do things for us, because unfortunately, we could do it directly. Like we could, you might be asking, why don't we just cut out the middleman? Why don't we just talk to the computer directly? Well, we don't really want to do this, because if we want to speak the machine's language, it's quite different to our language. So the shell tries to be an intermediary. It tries to provide a language that it can understand, which it then translates into something the machine can understand. So it's really quite convenient. It's really quite helpful to have. And yeah, we're much better for it. Trust me, no one wants to be interacting directly with the machine. And the terminal, so this thing here, which I will be swapping back between at various times in this talk, this is a terminal. And a terminal is basically just a program that allows us to use a shell. And I see we've got a question from Blake. So the terminal is a visual interface for the shell. Exactly. That's exactly what they are. So they run a shell, and yeah, because like it's fine for a shell to exist, but we also need a way to run the shell, right? So that's what a terminal does. Yeah, but a visual interface for the shell, that's a pretty good way of putting it. So why should I care? You know, we've got graphical interfaces now. We can just click a button. Why should we care? Well, although those things exist, the shell is still very much crucial. So we still use it today. You know, that was the way you interacted with Unix back in the day, like 50 years ago. And it's really a testament to its usability that we're still doing that 50 years later. So obviously it must be good for something. So if you know what you're doing and you have a specific purpose in mind, it's much more efficient to just use the shell to do something. So if you want to look inside a folder and look at its contents, well, one way you could do it with the graphical approach is you could open your file explorer, you could click a few buttons to navigate to the folder you want to look at, and then you can visually inspect it. Well, that's great, but I can just do this from the shell. I can just type ls. which once again, we'll get to later, but I assume that probably most of you know what ls is. If not, it's something that lists all of the files that you can currently see. But yeah, that's a lot quicker. So if we just type ls, that's much quicker than having to go through all of that, file explorer, clicking, all of that. It's also a universal program. So whereas a graphical thing like a file browser can only look at files, it can't browse the web for you. It can't look at a website. It can't run a program. It can't do any of that. It's just for interacting with files. So a shell, on the other hand, can do a lot of things. You can write files, you can move files, as we'll see. You can do a whole lot of things with the shell. So it's really one universal program that does a lot of things that, yeah, we don't have to install a graphical application for every little thing. So that's why you should care. That's why this shell is so special. So I notice we have another question from Blake. I've heard the terminal in VLab referred to as a terminal emulator. What does that mean? Yeah, so they're often called a terminal emulator because back in the day, they were like actual terminals. So like, if you think about it, if you have like a typewriter, that is kind of like a terminal. You're pressing the buttons on the typewriter, you're doing all of that. That is considered a terminal, but that's not directly the function of your computer. So your computer is not a terminal like that unto itself. So what we do instead is we run what we usually just abbreviate to as a terminal, but like you say, is actually a terminal emulator. We do that to emulate that sort of function. So I guess the answer to that is that a computer is not just a terminal in the old classical sense of like a typewriter. And as a side note, if you delve into a lot of Linux theory, which you may come across in further comp courses, you may come across this sort of typewriter notation quite a lot. There's these things called TTYs, which I won't bother explaining, but you might see during your time here at UNSW. That's another thing which is inspired by this notion of a typewriter. So yeah, there's quite a lot going on with typewriters, but that's why we call it a terminal emulator. Right, so we'll move on. So we've explained what a shell is, but anyone who's poked around a little bit or read a little bit online, they might have found out that there's multiple shells. So there's not just a shell. Since we're talking about Unix here, the most common Unix shell is something called bash. So earlier on in the talk, I said that if you want to follow along, we're going to use the bash shell. Well, this is why I said that, because there's quite a lot of shells that we can think of, we can use, that are used today. The most common one on Linux is typically bash. And this ships as the default shell for many variants of Linux. So in particular, if you use something like Ubuntu, if you've ever heard of that, that ships with bash by default. If you use something like VLab, then the shell that runs on that by default is bash, unless you change it, which I'm assuming most people haven't. Well, we just got another question. Do terminals only support specific shells? No. So you can run whatever shell you want. So I'll go more into this after I finish the second point, because that's actually relevant to the machine I've got here. But I can give you a nice example of this in a minute, but I'll just cover this point first. So the default shell on Mac OS, which I said was the other sort of main Unix derivative today, the default shell on that used to be bash, but because of some licensing things, they use something called ZSH nowadays. But this ZSH thing, it's just another shell, and it's very similar to bash. But now getting back to Blake's question, to prove that we can use multiple shells, the shell I'm using for this talk is the bash shell, like I said, but I've also got the ZSH shell installed, and this is the one that I use when I'm not giving this talk, basically. And I can run the shell here. So you can see that things are different now. I'm in the ZSH shell now. So a terminal is not strictly just required to run one specific kind of shell. It can run whatever. So at the moment I'm using ZSH, but because I want to keep things simple, we'll go back to bash here. But no, it's not restricted to just one shell, so you can run multiple. And for what it's worth, there are different shells from bash and ZSH. So if you're using Windows, you get something called PowerShell, which is sort of similar to Unix and all of those Unix shells, bash, ZSH. It's sort of similar, but this isn't a Windows talk, so I'm not going to talk too much about PowerShell. Maybe this is something we can save for the end if there's time. But the point I'm trying to make here is that the concept of shells is not just a Unix thing. So Windows has a shell as well. And you can also, with things like WSL, if you've perhaps heard of that, you can also run these Unix shells on Windows. But again, this is something we'll talk about at the end if we have time. But to avoid confusing people, I won't go into it now. Shared dot files. After this talk, maybe we'll talk about dot files after this talk. Oh, I've got a really good question here. It was sent as a direct message, so I don't know that other people can see it, but Priscilla has asked, what are the differences between the shells? Is there a reason you'd change shells? This is an excellent question. And to avoid getting into too much detail, the reason why I and a lot of other programmers use ZSH is that ZSH gives you a bit more customization. So nowadays, the extra support for things like, I don't know, we'll wind back a bit here. So when I went into ZSH, you notice that this James at Amos thing here that we had with bash, this has changed to this sort of blocky thing here. So we'll go into the anatomy of what's happening in the shell in the next slide, but to explain this one thing now, this is called a prompt. And a lot of people spend a lot of time trying to customize this prompt. And you can do the same on bash. It is possible, but all of the customizations that you can do to your shells, it's generally easier to do this on ZSH nowadays. So all of these tools are more mature on ZSH than they are in bash, but fundamentally you can do them on bash as well. But in terms of differences, you should use ZSH over bash aside from these sort of like aesthetic customization changes. Yeah, that's really quite a complex topic. We can try to save that for the end of the talk, but I think even then that may be biting off more than we can chew. But I guess for now, the thing to remember is that I guess the main reason a lot of people use ZSH instead of bash, for example, or they change shells, is customization. So a lot of people like pretty colors, basically. That's one of the main reasons nowadays. But there are some more technical reasons, which I won't bother getting into now because I think that's a workshop in and of itself. So hopefully that answers your question. But yes, there are definitely reasons to switch shells. So if there's no more questions on this, I'll move on. So we'll go over the anatomy now. So this is an example of the bash shell, which is running on a terminal, and it's running on Linux. So it's running on Ubuntu, which is a variant of Linux. So to kind of point out the things which are going on here, this whole window is the terminal. And this green and blue thing here, so this Chris at Ubuntu kind of thing, this is, like I said before, it's called the prompt. So that we can distinguish what we type in from what we get out as output, it's usually nice to have this prompt here. And there's other things this prompt will do. So when we get into actual commands, I'll talk about what this tilde thing here actually means, but it provides you a bit of extra information as well. So if I look at this prompt, I know that my username is Chris. I know that my machine name, so the name of my computer, is Ubuntu. And as I said before, we'll get into what this tilde thing means very soon, but that's another piece of information. So this prompt really is just, serves two purposes. It provides some useful information that we need to know when we're doing stuff, and it also sort of breaks up the text, because you can imagine that if we didn't have this here and it was just white text, like how can we tell what is just output and what did we run, especially if the output is not just quite as concise as what you see on the screen. So that's a bit of the anatomy of this sort of Unix environment that we're going to be showing off today. So we've got the prompt, we've got output, we've got this whole thing, which is running in a terminal. So I think now we'll move on to commands. So I talked a bit about commands earlier. I gave the high-level definition, but I think it's definitely worth jumping into what commands are at a lower level. So as a recap, to instruct the shell to do something, we pass it a command. So we might give it the ls command, which is the thing that I keep making reference to because it's a pretty simple command. So that's an example of a command. And each command will invoke another program. So ls is actually just another program on your computer. So when we type it into the shell, when we type the words ls into the shell, what we're really saying to the shell is execute this program that's called ls. And we can modify the behavior of this program using these things called flags and arguments. Now, I think we might talk, yes, so we do talk a bit more about flags and arguments here, but I've used some colors here to denote a couple of things. And I just want to pause here to give a little bit of a breakdown. So whenever I'm going to show off a command, I'll use this blue color here. Whenever there's flags in the command, which don't worry, we'll talk about what flags are in a minute, I'm going to use this, I don't know how you describe it, this sort of like a bluish green color. And arguments, I'm going to use this green color. So to show you an example of what it might look like, I might give a command like this, something which should be familiar if you've done comp 1511. So here I've got the command name. I'm going to put that in blue. I've got all of these flags, which are in this sort of color in between blue and green, and all of the arguments are going to be in green. So hopefully that should make it easier for you to distinguish what is what when I'm showing off these commands, because sometimes they might have flags and arguments, and it's a little awkward to distinguish between what's what. Speaking of distinguishing between what's what, let's talk about what these flags and argument things actually are. So we'll start with the arguments. Arguments are additional pieces of information that we provide to a program. So it's good if we can run a program, but what if we want it to, let's say, operate on a file? So we might want to give it the name of a file to do something with. So it doesn't really matter what the command does. Let's just imagine we have something and we want to give it the name of a file and it should do something with the contents of that file. Well, if we don't know what the arguments are, or we don't give it any arguments, the program doesn't really know which file to use. So we have to specify it. And we do this using arguments. So I've used this file name argument example because it's quite common. So you quite commonly see with a command, a common argument to that command is just the name of a file. So we'll get into flags now. So I've covered arguments first because technically speaking, flags are just a specific kind of argument. But their meaning and their significance is quite distinct from general purpose arguments. So usually what we use a flag for is to toggle a behavior of the program. So just as an example here, we have toggling verbose input. So let's say that we have a command and it produces quite a lot of input. If we want to condense all of that input, or we don't want to have all of the input at once, the command might provide an option to give sort of a summary instead. So yeah, so if we run a command and it gives a whole bunch of output, then we might specify a command that trims down this output. Output, yeah, so I'm trying to avoid giving a specific example because I don't want to launch into the shell quite yet, but I don't know. I think maybe we might, instead of ditching this, this verbose output example, we might have a look at the example in the previous slide. So I've got this DCC command here, and we've got all of these flags here. So we'll go through the example here to give a bit more of a concrete example. So this WALL flag, basically what it's going to do is it's going to show all of the warnings that you might get when you try to compile your C program. So I don't know if you've ever used this flag before or you've ever seen anything like that, but if you write a C program and you do something that's not necessarily an error, but it might be a warning, DCC might pick up on that, and by default, it doesn't show these things, or it might not show all of them. But if we do want to show all of them, it does provide this flag. So if we want to show that, we specify this special argument, this flag, and that'll show it. So it'll show all of those warnings. And similar to this thing here, this does much the same, only it shows all of the errors. And this -O flag just means produce a file that has a specific name. But I won't go too much into detail with the exact discussion here, because this is more of a DCC thing. The point is, hopefully you should be able to tell that these flags here, they're toggling some functionality. That's really the main message I want here, because this isn't a talk about what DCC does. But hopefully I haven't lost you there. But yes, these are flags. And to continue with this example a bit to show what the general arguments are, these green things, we say file.c here. We give that as an argument because we want to tell DCC, hey, I want you to use file.c as our input file. And this file here, that's another argument which we give that says, what do we want the output file to be called? But once again, I'm not going to go too much into detail with this one because this isn't a DCC talk, but hopefully you have the high level understanding of what the difference between flags and arguments are and why we might need them. So that was quite a bit of talking. So I'm going to pause and wait for any questions if you have any. So it doesn't look like we have questions, but in summary, arguments are additional pieces of information and flags toggle some sort of specific output. Yeah, so I think that's all I wanted to say with flags and arguments. Hopefully you're across that. So now we move probably into the most complicated part of these basics, but it's something I feel I need to explain before we actually launch into the commands. So we have to talk about the Unix file system. And this is quite a deep topic, but I'm going to keep it very, very simple. So what this whole file system word means is it just describes how data is stored or accessed in an operating system. So how your files or how your folders are represented. On Unix, it uses sort of this tree-like structure. There's a diagram coming up which will show you why we call it a tree-like structure. And it's a structure of these things called directories, which you can sort of use with the word folder interchangeably here. Within these directories, you can have normal files, so C programs, or you can have other directories. So this is saying that you can have a directory within a directory. And you can go even deeper than that. You can probably see where this is going. So here's what we mean by the tree. You can see that this does kind of look like a tree, right? It goes from the top here, from this little thing here, this slash. We've got 4 directories here. This second one branches off into even more directories. And you can see that it keeps going. So basically, we've got all of these branches that start from this one common thing. We'll get into a bit more terminology, that slide which I accidentally moved on just then. But hopefully you should understand why this is called a tree. So this is a simple example of what a file system structure might look like on a Unix machine. So this is pretty similar to how it works on Windows. Like, you know, if you have a folder, you've got files inside that folder, you can kind of think of that as a tree as well. So hopefully this makes sense, because I'm going to be relying on this sort of tree thing for the next couple of slides. But this is a nice visual example of what I said here. So within this tree, there are a couple of special directories and files which we need to remember. So as I said before, where this tree sort of starts, what we might call the root of the tree, well, it's not surprising we call this the root. So the root of the Unix file system, where it all starts from, is the directory /. So every file on your Unix computer, so if you're using VLab, everything on your computer is stored under this directory. So it contains everything. It contains all of your programs, it contains all of your documents, it contains all of your music, it contains all of your videos, it contains everything. So this is where really everything lies. And yep, it's this /. So whenever you see just / on its own, that means the root of the file system. It's where it all begins. Another special one is the user's home directory. And this is where that little tilde thing from earlier comes in. So if we go back a couple of slides, you can see this tilde thing here. What this means is it's the home directory of the current user. So what we mean by home directory is it's the default directory when you open your terminal that your shell is going to run in. That's where you start. So typically when you're running on a Unix machine and you're dealing with, documents, files, all of that, it lives under this home directory. So this root directory here is quite complex. It's got quite a lot of directories because it's got everything in the system. But this home directory is really for the personal stuff that you use. So all of the documents, because a lot of this, like, I don't know, you don't need to see the program files that are associated with Google Chrome, for example. You don't need to see all of that. But if you just want to edit all of the documents you write, maybe some homework, then it's much more convenient if you keep this in the home directory. So that's what we mean by this little tilde thing. And another minor point is that there are two other special files, directories rather. So every directory except root, so this / here, in addition to all of the things like its documents or its videos or whatever, it contains these two special files that refer to the directory itself, that's the single dot, and the directory that it sits within, which we call its parent directory. So that's the double dots. So you can imagine the documents folder lives within this tilde home directory. Well, the ... in that documents directory would refer to this home directory. So, I mean, perhaps a visual example is better here. If we're in this yellow thing here, this Z123456 directory, this will contain a ... and the ... will refer to this Turing directory above, because that's its parent. That's the folder it directly sits within. But the single dot is just going to refer to Z123456 itself. So hopefully that makes sense. I notice we've got a couple questions. So is home as the home directory a Unix thing or a VLab thing? It is a Unix thing. So this is where if you have a typical Unix system, so Linux or Mac OS, that's pretty common. So pretty much everything, unless you're running some really obscure customization, is going to be that home directory. I assume the everything comment is in reference to root. Yes, quite literally everything. So when we talk about removing things later on in this talk, yeah, I will have quite an important point to make, and it has to do with this root directory. You may be able to see where it's going. Your last question, when would you refer to the directory itself? So this is a good question, and it's one we will come back to and answer later on in this talk once we get into looking at commands. But if you've ever, to give you a simple example, if you've ever run a program which you've compiled in comp 1511 and you've done something like ./program name, that dot in the / means the current directory. So that's one example of when you would refer to the current directory. But the full explanation of that is quite complicated. I'm not going to get into it now. Like I said, if there's time after we're done with the commands, then we can try to explain it then. But hopefully that should make sense. So does the slash mean run? Not really. As I said, we'll get into this later on, but to give you a quick explanation, the dot slash, I won't go into it. This is probably getting too off topic and too complicated. So if we do have time, we will come back to it at the end. So if we have these files and directories in our file system, it would be great if we knew how to refer to them. So files in the Unix file system are identified by what we call a path. And typically this path is from root. So from this slash directory here, the path we need to take all the way down to get to a specific file. So yeah, so we'll go through an example for this yellow directory here, but you can imagine the intuition behind why we call it as a path. It's the path starting from here. Which way do we have to get in order to get here? So the Z123456 directory, that yellow one from before, the path we take is starting from root here. We go into home, then we go into Turing, and then finally we get into that yellow directory. So we're here. So from root, we go into home, then we go into Turing, and then we go into Z123456. So, and the slash, so the dot, yeah. So the dot means the first path of our path is the current directory, yeah. And the slash separates it from the name of the file we're running. Yeah, exactly, that's how it is. So a bit of terminology here. This path we have here, this slash home slash Turing slash, I'm not going to say that because that's a mouthful. We call this an absolute path. And we call it an absolute path because it's starting from, I guess, the absolute root of the file system. So starting from the very top, this is the absolute path we have to take from the top in order to get there. But as we will see now, there's another kind of path. So for this example, it's quite short. So this is in a real Unix system, this tree would be a lot more complex. It would be a lot bigger. So this is just a sort of contrived example which shows off the general structure. But on your real computer, this structure will be quite a lot more complicated. And as this directory structure gets a lot more complicated, you can imagine that these absolute paths just keep getting longer and longer. And it becomes a chore to refer to it, these things in deeper directories. So we have this thing called a relative path, which allows us to refer to something relative to something else. So to sort of motivate where we're going with this, if we're currently in Turing, then if we want to refer to Z123456, it would be really great if we could just specify its position relative to Turing rather than relative to root. And sure enough, what we'll see, well, we'll see a slightly different example because in this CS241 folder here, which lives within this yellow Z123456 directory, there's this file. There's this p1.cpp file. And if we're currently in Z123456, then the relative path of that file is going to just be cs241/p1.cpp. So one thing to note here, the difference between an absolute path, there's two differences. One, it's a lot shorter, and two, there's no leading slash. So in the absolute paths, you notice that everything started with a slash. That's not necessary here. So for a relative path, you don't have to specify a slash. So you can see that this is a whole lot shorter than specifying the full path because we'd have to go here, 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 and here. And you can see that as these trees get deeper and deeper, this is just going to become totally unworkable. So we have relative paths to keep our lives simple. So the first slash is an actual directory. The rest are just dividers. Yeah, exactly. That's how you think about it. So the first slash in the absolute path refers to root, but the rest of them are just dividers. So this slash here means that this Turing thing is a directory within home. Yeah, so that's exactly what it is. So why we want relative paths? Well, this just makes it easier to refer to a directory's contents. And we'll see that as we get into commands, which I think, yeah, we're ready to actually get into the practical part of this talk. So that's a lot of dense theory if you're new to all of this. So I'm going to pause and take some questions. So is one of the VLab computers called Turing or something? No. So this is, it might seem that way because we've got like things that look like ZIDs. This is just an example I found on the internet. This is not a reflection of what happens on the VLab machines. So if you wanted to look at the directory structure of a VLab machine, it wouldn't fit in this slide. It'd be quite a lot more complicated. But that's a discussion which I don't really want to get into because the VLab and CSE structure is quite complicated. So I'm just going to refer that to your own personal reading, ask around if you want to find out. But yeah, I'm not going to go into too much more detail. Is there any more questions that anyone has? All right, I'm going to take the silence as no questions. So at long last, 50 minutes into the talk, I think we'll finally get into commands. So we'll start with file system commands, just because we're fresh, that we've just covered the file system. It should be fresh in our heads. And this is really where it all starts. We have to know how to move around the file system in order to do anything really in Unix. So the first step is you might want to find out where you are in the file system. So the directory the shell is currently inside, we call that the working directory. And when your shell first starts, this is that tilde thing from earlier. So we'll switch over to our live demo now. If we want to view the current working directory, we type the command pwd. So notice that this doesn't have any arguments. So just typing pwd, that's all you have to do. So pwd, that's our directory. And what we'll note, as it says in the slides, is that this is an absolute path. So if we look here, it looks like an absolute path. Now, one minor point I would like to make here, because it probably doesn't look the same as maybe it would if you're following on VLab, the directory structure inside macOS is a little different. So if you're running on VLab, when you typed this pwd command, you probably saw something like this. So /home/username. Actually, on VLab, it'd be a bit more complicated, but basically you should see something like home/your username, which in this case would probably be your ZID. So on Mac, this is a little bit different. That home folder is called users, but this is really just semantics. There's not much of a, whoops, I'll make this text a little bit bigger. Yeah, so there's not really much of a difference. This is just a Mac OS thing, but you can see that this is still, regardless of where you run it, it's an absolute path, which I note down in this slide. So one kind of thing which you might be surprised is I said that this blue part in the prompt from earlier, that's your current directory. But when I printed the working directory with pwd, it didn't show this tilde. Well, what's going on here is this tilde is special. It's what's called a tilde expansion. And what it means is it expands to be the home directory of the user. So that home directory, which we referred to from earlier, this user's home directory. We said it's referred to as this tilde. Well, it has a defined like absolute path within the system, and we can see that by using the pwd. But note that it will not show this tilde thing when we type this command. So this is just for convenience. This is a bit of symbolism. When we see this tilde, we know it is referring to the home directory. So that's one little minor point which I'd like to make here, because that might be a little bit confusing. So is everything above the home directory all OS stuff? Yes and no. So if I were to, I'm going to do something which you may not know what I just did. If I go up one directory, which we'll talk about in probably the next slide, the thing that the home directory is in, it contains a bunch of other home directories as well. And these home directories are going to be all of the individual users on your computer. So you can see here on my computer, I've got my James user, which was the working directory I had before, but I've also got this shared user, which is from memory the thing on a Mac OS computer where you can use a shared user that isn't basically your main one. So if you want to give your computer to someone else to use and you're really paranoid, you might use the shared user. But inside this users thing here, or /home, if we're running on a Linux computer, there's going to be all of your user files, all of your user directories for your computer. So those aren't typically OS files, but certainly if we go up one more and we have a look, all of this is pretty much OS stuff. So the answer is yes and no. But to keep things simple, you can almost think of it that way. Just there is one exception. If you have multiple users on your computer, then you'll see all of those users there. But yeah, not just strictly OS stuff, although most of it is. So I think that's all I wanted to talk about with pwd. It's a fairly simple command. Just remember that it is an absolute path and that this tilde thing, it didn't show up, but I've explained why. So if we want to view the contents of a directory, this thing which I showed off earlier, we can do ls. So when I type ls here, I'm going to show all of the content in that directory. So you can see that I've got, if I can count properly, I've got 10 directories. So I'm not going to bother listing all of them, but this is what's in my home directory. And you can see why this might be, this might explain why I said this is where all of your stuff is, because look what it's got. It's got my documents, it's got my downloads, it's got my movies, it's got my music, it's got all of that. So this is why we call it the home directory, basically. And ls allows us to show the contents of a home directory. We have a question, so I'll back up a little bit. Are other third-party programs generally installed above the home directory? Yes and no. So some commands will install in the home directory here. I'll talk a little bit more about this in a second, but it really depends. I'll keep the answer simple. It depends. So not always, but sometimes, yes. I've got a question about recording. Yes, there will be a recording. So this meeting is currently being recorded. I don't know when it'll be made available, but there will be a recording. So if you're not able to stay around for the whole talk, the recording will be made available. So if you've got a lecture or something, feel free to jet. There's no stress. Is the root directory different to the home directory? Yes. So as I said earlier, the root directory is where everything starts. So every file on your computer lives in the root directory. And your home directory is one of the things that's in this root directory. But if I go and sort of demonstrate more of the power of ls now, we can use it to list more than just what's in the current directory. If I go ahead and specify the root directory and we have a look at what's in there, we can see a whole bunch of other stuff. And this is decidedly different to what we have above. So this little block of input here, this is the contents of my home directory. but this is the contents of my root directory. And you can see that they're two different things. So yes, they are different. So this directory here, this is all of the folders, all of the directories that exist on the system. Everything that's on my computer, it's on there. So it's in one of these folders. Hopefully that answers your question, but I'll continue talking about this. So you might wonder why it's called ls. Well, here, if on these slides, if I can try to give the explanation, I have. So in this case, I've highlighted L and S in list. That's where ls comes from. So list ls. And with this ls command, we can give it flags and a path. So I've demonstrated giving it a path. So I gave it this slash here from earlier to give you a bit of, but this is an absolute path that I've just shown. So this slash here is an absolute path. And if I wanted to be really cheeky, I could essentially get the same output as I have here by specifying the absolute path of my home directory, and sure enough, it matches. So this is a absolute path. But if I wanted to look at what's in the documents folder, well, actually, let's pick something like dev. If I wanted to look at the dev folder, I can use a relative path. So the relative path of this dev folder with respect to my home directory is just going to be dev. And if I list it, here are all of my things. So you can see within my dev folder, I've got 4 separate folders. But to sort of bring the point home, if I go like this, if I specify the absolute path, I can do that too. But you can obviously see why it would be more convenient to do the relative path. So that's the path. So as you may have been able to tell, if you don't give it a path, then the working directory's contents are shown instead. So that just happens to be whatever directory you're currently in. So if you imagine I was in the dev directory, which we'll get into how to change into this directory in a second, if I just typed ls with no arguments, I would basically just get this output here. So if you don't provide ls an argument, then it just defaults to showing what's in the current directory. But you can show other things that aren't just the current directory. So we'll talk about flags now, a couple of nice flags. You can see that in this ls output here, it's all in a list. But if I want, like in a straight line, but if I want to give it in a list sort of downwards fashion, I can specify the L flag. So now if I do that, you can see that everything is listed in vertical format rather than horizontal format. And you can also see that with this, we got a couple of extra things as well. So we got some random strings here, which I won't go into. Although I will note that this column of numbers here, this is how big the files or folders are. So this is measured in bytes. So that's one sort of aside from the names of the directory, this is, I guess, the other more explanatory field that you get here. But yeah, there's a whole bunch of output here. I'm not going to go into detail about what all of this is, but just know that if you use the L flag, it gives it in this list format. And if you want the names of the directories, that'll be the stuff on the far right. If you want to show hidden files, then you have to use the A flag. So I'll run normal ls and ls with the A flag. You can see that if I use the A flag, I've got a whole bunch of extra files that have been listed now. So ls-a does this thing called showing hidden files. So you can see that all of the files and stuff that got shown when I ran ls without the A flag, it doesn't have a dot in front of it. It's all just a word, right? So it's all things like applications or desktop. If I want to create what's called a hidden file, I should rename it to where the first character in that file's or directory's name is a dot. Then it's hidden. So it's called hidden because when I run ls normally, I can't see it. So a lot of these files, they're all just configuration files. And there's quite a lot of them, and maybe I don't really care about what these configuration files are. So by default, they're hidden. But if I do want to see them, I have to use the -a flag. So to answer the question in chat, the ls-a command shows hidden files, which are all of these files that are prefixed by a dot. So these are all hidden files. So I think that's all of the things for ls I want to show off. Is there a way to remember this? Like -l, I can think of it as a list. So I don't know if this is quite correct, but I suspect the A is for all. So ls-a means show all files, not just all visible files. So I'm not quite sure if that's exactly what the A means, but I think that you can probably remember it with just saying all. So -a for all. And as Blake has pointed out, this is something I'll come back to later. Yeah, okay, I won't bother acknowledging this for now because it's something I plan to cover later on in this talk. So that is ls. And one last thing is you can do both of them together. So if you want to show all of the folders in a list format and you also want to show all of the hidden files, you can type -la. Yeah, I won't acknowledge the point, but I will acknowledge you. Blake has a good suggestion, but I'm just not going to go into the point because it's getting ahead of what I want to talk about. But as you can see here, with all of this output, you can see that we've got it in list format, and we're also showing all of these hidden dot files, right? So once again, to run that, we put -la together. So you can do that. You can combine these flags, which, by the way, is just, I think, equivalent to specifying them individually. So ls-la is the same as doing ls-l-a. And it goes without saying that I can show, I can use flags and a directory at the same time. So that's just me doing the listing and showing of hidden files in my dev directory. So it does work. So I spent a lot of time on this one because a lot of what we saw here is going to be somewhat similar for the following commands. So next, we'll get to moving around. So we've covered how to look at where we are. We've covered how to list what's in where we are, but we haven't talked about how to move. So if we want to change our working directory, we use the appropriately named CD, and we give it a path. So this path is where we want it to be after we run the command. And this path can either be absolute or it can be relative. And if the path is not given, so if we just type CD on its own, then it defaults to just sending you back to your home directory, so this tilde directory. So as a demo, let's say I want to move into my dev directory from before. I just type cd dev, I'm in there. If I want to move back into the home directory, from here, I'm going to show off two ways of doing it. So the first way, like I showed in the slide, is if I just type cd, then I get sent back to home directory. So this doesn't matter where I run it. So I could be deep in this dev directory. It doesn't matter where I run it. If I type cd, I'm going to be back in the home directory. So we'll go back in. I'll show you the other way. If we use the parent directory thing from before, since this dev directory is directly in this tilde thing here, we can use ... to move up to the start again, like that. So in this case, we're moving up to the parent, which is our home directory. So there's two ways of doing it. So you don't need to add the tilde. Yeah, exactly right. So if we go into dev and we type tilde, I guess this is a third way to do it as well. Yeah. So one thing which you might need the tilde for is if you want to cd into something that's in the home directory from deep within. So let's say, let's go into university, into my folders. So let's say I do some stuff here. And now I want to go back into a different folder that's under this home directory here. Let's say I want to go into my music folder. So if I want to do that, I want to specify a relative path from my home directory. I start with tilde, and then I use music, if I can spell. And now I've changed into my music directory. I don't know that I've got anything in here. No, I do not. So if you just want to get back to the home directory, you don't need the tilde. But if you want to directly move from something like a subdirectory here into something that lives within the directory rather than having to do all of this going up and up thing, because you can chain all of these dots together, right? And you can just keep going up one level. But if you just want to jump directly to it, you can use a relative path from tilde up to this music folder, if that's the one we need to go into. So hopefully that makes sense. And as before as well, we can use absolute paths. So that's an absolute path for my home directory. So now we're in there. If I want to go into dev using my absolute path, I can do that as well. So you can use relative or absolute paths. In practice, you probably want to use a relative path. And cd ... to go back up once again. So those are sort of most important uses of cd. So that's moving around. So now we know how to change. I guess the next little step in our exploration of the file system is we want to create things. So we want to create a directory. So if we want to create a directory, then we use this mkdir command. So the mk comes from make, and the dir comes from directory. And we specify a path. So one thing to note here is that path must be a path to a directory that does not already exist. So to give you an example of that, let me change into the Unixverse folder, where I think we're going to be living for the rest of this talk. You can see that I've got a whole bunch of files in here. And I can't remember off the top of my head which of these are directories. I think this songs is. If I want to make a directory called songs, it can't already exist. So we can see that the directory songs already existed, so it gave me an error. But if I want to call it new songs, for example, nothing wrong with that. So the important thing here is that the directory cannot already exist. So we couldn't create another songs directory because there already was one, but there was no new songs directory. So we're allowed to do that. So the command will fail otherwise. And you can create multiple directories at once. Sorry, I'll back up a bit. Why does the terminal refer to the directory as a file? This is a good question. So directories are really just a special kind of file. So when I was talking about the Unix file system, I gave a very simple view. So I distinguish between files and folders. As far as the system is concerned, they are pretty much the same thing. It uses another abstraction. Like, these things are not represented as either files or folders. I'm not going to go into this abstraction because it's getting off the topic of this, off the scope of this workshop. But if you're confused as to why it's saying a file exists, it's because to the system, the directory really is just another kind of file because it's working with another layer of abstraction. But to the user, the notion of a directory and the notion of a file, they're two separate things, but to the system, they're not. So like I said, you can run multiple creation of directories at once. So if I wanted to make a whole bunch, let's say I wanted to make 2, I can do that. So I can create 2 songs directories, new songs directories at once if I wanted to. One thing which I want to show off is that if you want to create a subdirectory within a subdirectory, so let's say within new songs, I want to create a directory for pop, I can do this. But the one caveat here is this new songs directory here, this one does have to exist. So if I'm going to create something in a subdirectory, like the end directory which I want to create, this pop folder, that can't exist. But if I want to create it within something else, all of those things that I'm trying to create it within, all of that does have to exist. So this new songs / pop, for this to succeed, this new songs directory, which we created earlier, that had to exist. So that's one minor point I want to make. Yeah, so you can create multiple at once and the directory cannot exist. But if you want to create a nested thing from within a parent directory, all of those things in the directory chain have to exist, if that makes any sense. So that new songs, this directory had to exist, but now if I wanted to create rock, this is fine as well, because that rock directory doesn't exist. But if I try to create pop again, then it already exists. There's also mkdir/p. Yes, there is. I don't know if that's Unix or just Linux either, but yes, that's definitely something you can look into as well. So creating a new file. So we've talked about creating a directory. How about now creating files? So this is the first command, I think, where the name of the command doesn't really match what it does. So the command for creating a new file is touch. So I don't know why it's called touch. Maybe someone in chat might know the answer to this, but I don't know. Just remember, if you want to create a file, it's called touch, and you give it a path. And as before, this path can be absolute or relative. Most of the time, you probably want it to be relative because that's easy to work with. And once again, the file cannot already exist. And if you want to create, so for example, let's have a look at what we've got in here. So if I want to create a new repeat.c program, whoop, hello, I did not know that that happens. We're learning something in real time, folks. Okay, so the file can exist, but if it already does exist, then typing touch just does nothing. So if you try to touch a file that already exists, it just does nothing. When would you want to create a new file with touch rather than with an editor? Yeah, good question. So if you just simply want to create a file and you don't want to do anything with it right now, you want to do something with it later on, or you just want to ensure that the file exists for some other program you're creating, that's when you probably want to use something like touch. Yeah, so something like shell scripts probably is a good example, but I won't go into shell scripting and all of that because that's quite a deep topic. So you can create multiple files at once. So we can do file 1, file 2, and that creates more than one file at a time, as we can see here. So essentially the semantics for make directory and touch are the same. It's just that make directory makes a directory and touch creates a new file. So now we enter the danger zone. So removing a file or directory. So this is something I alluded to earlier. This is quite dangerous. Yeah, so if we want to remove a file, we use this rm command. And we can give it some flags, and we can also give it, obviously, the path that we want to delete. So I guess we'll cover deleting files first. So if I want to delete one of these files which I created earlier, I can type rm file 1, and now if I show the contents, it's gone. So we no longer have a file 1 in here. And if I want to delete more than one thing, let's say I want to delete some of these program files. Let's say I don't like HTML, so let's say I delete that one. And let's say I don't like C++, so I delete this one as well. So we can remove multiple files at once as well, and they're gone now. I think I just use an editor to create a new file, then save it. Yeah, so that's usually how you'll do it. But if you wanted to do it from just the terminal, then you can use touch. But just using an editor is fine. So that was deleting files. You can also delete directories. And here is really where the danger starts. So let's find a directory here. So this songs 3 thing here, I don't really want this anymore. So let's say I want to delete this. If I want to delete a folder, I have to use the -r flag. So if I want to remove this folder, rm/r songs3, and now it's gone. So if you want to delete a file, you don't need to use -r. However, you can still specify it anyway, and it has the same effect, which is to say that if you want to remove a file, rm-r file and rm file are just equivalent. They do the same thing. So you don't have to specify that, but you can if you want, still works. And obviously, like I said, you can delete multiple things at once, as you can create multiple things at once. The warning here, this be very, very, very careful part, is deleting things, there's no way to recover from this. So it's not like deleting a file, maybe if you're used to, where if you delete something in the graphical file browser, it gets sent to a bin. This does not happen with RM. Once you delete a file, it's gone. So you need to be very careful when you're deleting something. And you need to be especially super duper careful when you're deleting directories. So I'm going to get nervous just typing this, but one thing which you might see a lot is rm-r/. So you should absolutely by no means run this command, because what this is going to do is it's going to delete, obviously, in directories, because we're using -r, and this slash, we're going to delete the root directory. So this is just going to delete everything. So this is really going to be quite bad if I run this. So I'm not even going to play with that. I'm going to get rid of that. If someone tells you to rm-r/, just don't do it. Just don't do it. Simple as that. So -r is recurse. Yeah. So the R is just for recursive. So it recursively deletes things, if you know what recursion is. So the bin directory is not a rubbish bin. Yeah, not a rubbish bin. The bin directory, I think that just means binaries. So that's where program binaries, i.e. the things that you run in order to run commands. So like if we type ls, the command or the program that we run when we type ls, that's typically stored in this /bin directory, which Paul has just said. So let's go have a look in here. If we have a look, we've got all of these commands. So you can see here, we have that ls thing. So this is the program binary that ls, when we type it in, actually runs. This is the thing that actually does the listing of the directory. So yeah, this /bin thing is definitely not a rubbish bin. Definitely not a rubbish bin. Try it, you won't have permission anyway. I mean, you're right, but I don't want to do it. Okay, so now we'll talk to copying. So we've talked about creating, we've talked about removing. What if we want to copy things? So if we want to copy a command or a file, we use cp, we specify some flags, and we use a source path and a destination path. So so this source path must already exist, but this destination path, what we want to copy it to, doesn't have to exist. So let's jump into an example here. Let's say I want to copy my repeat.c program. It's this one here. So let's say this is the source that we want to do, and let's give it another name. So let's say we want to copy this file and we want to call it repeat backup.c, because maybe we want to create a backup. So now if we look, we've got a repeat backup file. So that's copying a file. If we want to copy a directory, we still can. As with RM, we're going to use the -r flag. So if we want to copy our songs directory, and we want to call it, well, we've already got a new songs directory, so let's call it dad songs, because maybe they're the songs of my dad. Now, if we have a look, then we've got dad songs, and this is just going to be a copy. So all of the contents of this dad songs directory are going to be the same as they were in songs. And I think that's all I wanted to say with copy. Yeah, it's a pretty simple command. It's just copying. This destination path refers to what you wanted to call it. An example for where you might want to use dot, so from earlier, let's say I wanted to copy something from a different directory. So let me go looking for something to copy. Say we have sample here. So we have some hello world files. Let's change back into Unixverse. Let's say I want to copy hello world.c into my Unixverse folder, but I just want to call it hello world. I don't want to change. So we'll use cp. We'll specify a relative path. So now sandbox hello world.c. And now, because I want to keep the file name, I'm just going to use dot. So this dot just means current directory. So if I use that and now I look, we have a hello world.c file. So this saves me having to type hello world.c, or more specifically specify the exact directory which I want to do it in. So this is just a reference to the current directory. If I don't give it a name, it's just going to be the same name as the file. So in this case, hello world.c. So we've got a question from Blake. Can you change from the cursor block that covers up a letter to a vertical bar or something in the terminal? Are you asking me to do it for the purposes of this talk, or are you just asking just out of curiosity? Because the answer is yes, you can change it. It depends on what your terminal emulator will let you do, but most ones, yeah. Okay, so if you're just curious, yes, you can. I'll cover it at the end if we have time, although with how we're tracking for time, I don't think that we will have time for all of that. But I don't know, maybe if we've got a bit of extra time, maybe we'll stay for a couple of extra minutes. But I think that, yeah, I'll leave it at that. But yes, you can change it. So I think this is the end of the file system commands. So let's talk about moving. So we've talked about copying things. So we copied a whole bunch of stuff in here, but let's say I want to move something. So instead of copying it, creating another copy, I want to move something from one directory to another. So if I want to move a file or directory, I use mv. I use source path and destination path. So one thing which you might be noticing here is that mv doesn't have flags. So mv will work with either a file or it'll work with a directory. It doesn't care. So you can use mv to move files or directories without having to specify a custom flag. Tanit, that's a great question. I'll get to it. It's actually my next point. So if you're moving something and the destination path already exists, then it'll overwrite whatever exists. So you should be careful. So mv is also a bit of a dangerous command. So if I move a file from another directory and there's already something of that name in the destination path and I don't give it a different name, then it's just going to overwrite what was already in it. So you have to be a bit careful. So yes, there is the risk of overriding. So as I said, unlike copying, you don't need to specify a flag. And I think now we'll show an example. And I'll also I'll just say this last point and then we'll do the example. The most common usage of this is when you want to rename a file or a directory. Yeah, so as Nick's pointed out in the chat, there are some extra flags if you don't want to overwrite, but I think that it's instructive to just ignore those flags at first and give people the warning that by default, move will overwrite. So we'll go back here. So let's use move for its mostly intended purpose of renaming. So let's say that we've just copied hello world, but I don't like the name. I want to call it something different. So we'll move this hello world.c. So we'll specify the path. In this case, it's just relative. This hello world.c is already in this thing. And let's say I want to call it, I don't know, goodbye world. It's a bit morbid, but let's say I just want to call it goodbye world. Then now the hello world file is gone and it's been renamed to goodbyeworld.c. Let's say now I want to move this back into my sandbox directory where I got it from earlier. So once again, we're going to specify this with move, and now we're going to specify a path. So we'll do sandbox, and we'll just say this, and this should just move it to so let's have a look. Go sandbox. We see we have a goodbyeworld.c thing here. Now you might be a little bit confused because doesn't this directory here exist? Well, it does, but the difference is I've used slash here. So this slash is different from specifying just this without the slash. If I ran this without that trailing slash, it would just overwrite the sandbox directory. So it'd move this goodbyeworld.c file and it'd call it sandbox and it'd remove the directory. So you've got to be very careful. And that's where this trailing slash really came in handy here. And obviously you saw there was no need to specify the file name if we just wanted to. Are you sure? I mean, should work. I'm not, yeah, screw it. Let's do it. Yeah, let's find out. So let's do this. Yeah. So good point, Kai. So it doesn't actually work like that. This is something I didn't know. So if you try to move a file to a directory which already exists, so basically you try to move a file and replace it with what already existed as a directory, it just doesn't work. Oh, actually, it doesn't work because I've moved it out. Whoops. All right. How about we try file.txt? How about we do this? Yeah, okay, Kai's right. So you don't have to do the slash. There we go. I learned something. So the slash isn't even needed. So if you specify it, it automatically just puts it in. Nice. There we go. Yeah. All right. I didn't know that. Yeah. So still just be careful, but that's MV. So I think that's it for the file system commands. We have half an hour. I don't know how I'm going to cover the rest of this in half an hour, but we'll try our best. So that's it for file system commands. Before we move on, do we have any questions? All right, I think we're good. So now we'll move to output. Oh, hello. How do you recover from rm-r/? You can't. So if you run that and you don't okay. So rm-r/, it should be safe because what you usually see people do is rm-rf/. So this F flag is something I purposely didn't show because I don't want people to be using it if they don't really know what they're doing. This F flag is going to ignore anything. So if you run it and there's warnings, then it's going to delete it come hell or high water. So it doesn't matter if you've got permission or not. It's just going to do it. So that's the one thing you have to be very careful with. Doubly dangerous if you prefix it with sudo. Yeah. But the OS is generally smarter than this. If you don't tell it to just ignore all of the warnings, it will try to stop you from doing that. So yeah, but still be very careful because even without doing some dangerous stuff like /, even RM with fairly innocuous use cases can be quite bad. Like if you delete a file which you have no backup of, you're done. So yeah, just be very careful with RM. So I think that's all of the go to an Apple store to test it. Oh, you're evil. You're evil. Don't do that. Okay, so I think we'll move on to output commands. So if we want to print stuff, so you're probably familiar with something like printf from C, or the shell equivalent of that is this thing called echo. So if I want to print something to the screen, I use echo and I give it a message. So this is really simple. So I'll just give an example. Whoops. Why are you not working? That's weird. Okay, I'm just going to ignore that happened. So if I type echo hello world, it just says hello world back to me. So echo pretty much just what you say says it right back to you. So there's another point here, this point here. I don't know that we have too much time to get into it. The shell interprets a command's arguments as being separated by space characters. So as you saw before, this hello world thing, it's separated by a space here. So these really are two different arguments. So echo will basically put back all of the arguments you give it, and it'll separate by a space. But if I want to just treat this hello world as one phrase, well, why is I don't know what's going on here. But if I want to just say this, and I want to treat it as one argument, I enclose it with quotes. So hello world, that's treated as one thing, but as you can see, to echo, it makes no difference. The particular choice of quotation marks you use does make a difference, but I don't know that we have time to cover that today. And that's a little bit of a complicated topic, but just to give you an example, let's say like this. Whoa, what happened? It didn't print -shell, it printed something else. Well, what if I tried with single quotes? What's going on? Yeah, so there is a difference with what kind of quotes you use, but it's not one that I'm going to get into because it's a little bit complicated and we're kind of running short for time. But there is a bit of a difference. Yeah, shell coding in week 2 is a bit rough, so I'm not going to bother with it. But yeah, just be careful. So the kind of quotation mark you use as a beginner is not very important. So is there any point to that, or is it just fun? Is there any point to echo? Yeah, so there is. So we'll get to that possibly later, or maybe not, because I think we might be running out of time. But there is a use case for echo. If you just want to say something to output, and then you want to feed that as input to another program, then echo can be quite helpful. So that's one possible use case. And also if you want to check something. So if you wanted to do this mysterious thing, which I'm not going to explain, then you can use echo to look at this. So this shows. So I guess to put it in one word, this is a variable, but I'm not going to say any more than that because that's just a whole different talk. What course does this quotation discussion? That's Comp 2041. So if you want to learn more about this, do Comp 2041. It'll talk about the difference, but this is something that I was going to save to the end if I had time. For the file that you get distributed to you at the end after you've completed the feedback form, the document I've got does have an example with a bit of an example and explanation for why that's true. So more incentive to fill out the form if you just want a quick answer, but I'm not going to cover it today. So I think that's all I wanted to talk about with regards to echo. So it's really simple. It just repeats what you give it. Yeah, so it did cover it in 2019, but I'm going to stop talking about 2041 now. So that echo thing is for printing one thing we give it, but what if we want to show the contents of a file? Well, we could just open it in a text editor, but what if we just want to show it in a terminal? Well, we can use cat. So this cat command, we can give it some flags and we can give it a path. Now, why it's called cat is that's short or an abbreviation or a shortening of concatenate. So what it's basically doing is it's going to concatenate the input file that you give it, the contents of that file, to what you see on your terminal. So we'll show that here. We've got a couple of files here. Let's say we want to show our text file. So there we go. We give it a file and it shows all of the contents and it prints out to screen. So what's the difference between cat and less? Yeah, we'll cover that very shortly. So I think that might even be the next slide. So yeah, this cat thing just took a file and it printed its contents back out. So if we don't want to open the file, yeah. So there's a flag being mentioned here if you want to see non-printing characters. Yeah, capital A, so we'll use that. Oops. Oh, okay. So this is a thing that's not going to work on my computer because on Mac OS it's a little bit different. But if you run this on VLab or something, this will work. But I don't remember off the top of my head what the equivalent flag for Mac OS is. -A, maybe lowercase -a. Yeah. Nah, doesn't matter. Man will be covered later, but yeah, we'll look at that later, but I won't overwhelm people so far. But yes, the one flag I did want to cover, the one that I know will work, is -n. So if I've got a couple of C programs in here, let's say I wanted to view the line numbers, hello world.c. If I use the -n flag, it shows me the line numbers. So in addition to showing me the content of this, yeah, does that. So it shows line numbers as well. So you can use -n. And you can also concatenate multiple files at once. So let's say I want to do goodbye world and hello world at once. It's going to print the same thing twice because if you remember, we just copied the file. It's the same exact thing. Yeah, so you can cat multiple files at once. So that's something you can do. And the -n flag, well, I don't know. Let's see. Does it work? I'm actually curious. I think it might. It just, yeah. All right. So if you use -n and you've cat multiple files, then the line numbers are reset for each file. So I guess that's a good way to tell which file is which. But in this case, they're the same. So it doesn't really matter. So that's printing a file with cat. So now to answer the question of less, if you want to progressively view a file's contents instead of just showing everything at once, you can use less and you give it a file. So you give it a path to a file. So let's say like this, here's less. So for a very short file like this, it doesn't make a difference. I'm going to actually, because this file's not long enough, I'm going to don't pay any attention to what I'm doing with this. Hello? Whoops. Don't worry. Okay. All right, never mind. How about we just give some, what's going on? Uh-oh. Oh. Okay, I don't know what's going on here, but some weird crap is going on. What have I done? I think I've just bricked my terminal. That's awkward. So what I'm gonna do is I'm gonna reset. So bear with me for a second. It's really awkward. Yeah. Text file is probably, yeah, quite a mess. So we're just going to ignore that that happened now. We're just going to move to something different. Is there something in here that's long enough that I can use? Okay. Does this have lines? Yes, it does. Yes, this will make it long enough. All right, now we can finally use less. So if I use less, I can progressively scroll through this output. So it may not look like it at the moment, but I'm scrolling through it at the moment. So I can keep moving down, keep moving up. So I'll go back to this slide here to show you how I was doing that. There's quite a lot of ways to scroll and navigate the output of less. You can use arrow keys if you want. That's one way of doing it. In my opinion, the best way to do it is the Vim bindings, as someone in chat has already pointed out. So Vim bindings, there's quite a lot of them, but I'm going to keep it simple. So the way I was doing it earlier is I was pressing, at the moment, I'm pressing K, which goes up. And if I want to go down, I press J. So J to go down, K to go up. And the reason why you should use this is because there's other commands that let you do stuff as well. Why is it quite okay? Why is it quite similar to git log? Yeah, that's a good point, because git log actually feeds all of the output to less. I'm pretty sure. I'm almost certain that's the case. Yeah. So when you run git log, it automatically puts everything into a less command buffer, really, which lets you do all of this. So yeah, J and K to move down and up respectively. One good thing about this is if I press G, now I'm at the top. If I press capital G, I jump to the bottom. So if you've ever used Vim before, this should be very familiar, but if not, lowercase g will take you to the top of the output and capital G will take you to the bottom. So this is really popular if you've got a really huge file and I just want to jump around from these locations. So if I just want to really quickly go to the end, well, instead of spamming arrow keys or J and K, I can just jump straight to it. So those are some of the Vim keys that you should use. And I guess the last one, which I haven't covered, if you want to exit less, you press Q and that's it. That just gets you out. So Q for quit, I guess. So my suggestion when you're doing something in less is to use the Vim keys. So J, K to move up, down, and G, capital G to jump to the start respectively. There's a couple of other things you can do, but I don't want to turn this into a Vim talk. So yeah, that's less. Less is very helpful if you have a long file. So if I was to cat this file here, that's really quite long. So if I don't want to scroll through it, all of this, that's a bit of a pain. But if I throw it into less, then it's better. So I think we'll move on to, the last part of this output thing. So now let's talk about showing the first or last couple of lines of a file. So if we just want to print out the start or end of a file and we don't want to use less, we can use these things called head and tail. So head shows the first couple of lines of a file and tail shows the last couple of lines. So they both accept flags, which we'll see in a minute, and they obviously accept a path, which is the file that you want it to show. So as an example, let's just show off head with our text file 1. By default, this is the first 10 lines. So if I don't tell it to do anything, it will show the first 10 lines. And now let's change this to tail. It shows the last 10 lines. So head, first lines, tail is last lines. If you want to display the first or last n lines, so not necessarily just 10, you can use the -n flag where you just replace n with the number. So as I said before, without any flags, both commands, they just display 10 lines. But let's say I want to look at the very first line, head -1. So head -1 will show me the first line. And if I go and change this to tail, it shows me the last line. And now if I want to look at the last 3 lines, we've got that. So hopefully that is pretty straightforward. I guess the one thing to remember is you don't want to leave n here. So you want to replace n by a actual number. So this is going to be quite helpful if you just want to look at the first line without having to actually open up the file. So you can just go and look this. Oh, that's the first line. Convenient. Yeah, so that's very handy. So that's it for the output commands. Does anyone have any questions thus far? I wonder if I'm going to run out of water in this talk. All right, I think we're okay. So let me have a look at where we're up to. Yeah, okay. So the 2 more complicated topics of this talk, I don't know if we're going to be able to get into it because we have 10 minutes left and I don't want to keep you guys too long. Actually, we'll wonder, like at the end, we'll see once we're finished with this one. If you guys want me to continue going, I don't know that we have any time limits. Kai, if you're still here, do we have any time limits that would stop me from going over time?
Nah, you can just keep going if you like.
Yeah, all right. So if enough people are interested, we can cover the last 2 topics. But If not, I'll just cover this last main part of the talk. All right, cool. So tools and navigation. So we've talked a little bit about using commands to interact with the file system, and we've just looked at some commands for dealing with output. This section is going to be a bit more about some quality of life changes or nice things to know, which make our experience using the shell a lot better. So looking up documentation. As has been alluded to quite a couple of times in this chat, there is a command you can use which you can view all the documentation. So there's a lot of commands and you're not expected to remember everything. And individual commands can be, all right, see you, Nick. Hope you enjoyed this talk. But yeah, so yeah, and for anyone else who has to leave, they've got a lecture or something, feel free. As I said before, this is recorded, so you can pick up what you don't see when you leave. So there's no stress at all. Getting back to it, there's quite a lot of commands, and these individual commands can be quite complex. So I can't really think of a command that has a lot of functionality, but you can imagine that like there's a bunch of flags. That's a really simple one. You're not expected to know what all of these flags mean. So if you want to look at all of this information, there is an incredibly handy tool called man. So let's say I wanted to look at the documentation for ls. So I can type man ls, and here we have that documentation. So you can see this just has all of the very detailed documentation for this command. Now, to navigate all of this, this is actually through less. So this is why I covered less. If you want to navigate man pages, you use whichever keys you use to navigate less. So all of the commands work. So if I type lowercase g there, I jump to the start. If I want to jump to the end, I can use capital G, and yeah, I can jump between basically very conveniently. So this is very powerful to know those less commands, but you can use arrow keys or J and K to move down. So if we look through this, it tells you what the command does in this description. And here, if we want to look at all the flags, here they are. And you can see there's quite a lot. So here's this, where is it? Let me see if I can find a flag. Yeah, so here's the -L. So this will tell you that the flag means list in long format. So if you forgot what -L meant, or from before, let's say you forgot what A meant, it's here. So this -A flag include directory entries whose names begin with a dot. So -A, basically the mnemonic is all. So if you forgot that, or you forgot any of these other flags, you can use these man pages to look. This is incredibly helpful. I can't stress how helpful it is to know that this exists. This is actually available in your exams. So if we ever return to having in-person programming exams, this man thing can be a lifesaver. So as long as you have access to a terminal, you have access to man, you're well within your means to use it most of the time. And knowing how to use it or knowing that it exists is really quite helpful. Yeah, so as has been pointed out, this man thing is not strictly for shell commands. So if I wanted to look at the documentation for the C function printf, then I'll type man-phi printf. So I won't go into too much detail about what the number means, but as a high-level summary, there's different pages within man, like different sections or chapters, I guess is probably the better way to put it. And this third chapter here is the one that has all of these C functions. So if I look at this now, I have all of the documentation for the printf functions, and I can scroll through it, I can have a read. What we look in and we can see here is there's quite a lot of variations of printf, probably more than you can, you've heard of or seen before so far in Comp 1511, and you're not expected to know all of these. Is this because Unix is built in C? Probably. I mean, C is common enough and used quite extensively within the Unix operating system that it probably makes sense to have these pages. So yeah, probably. That's probably the reason. So yeah, I think this is probably the more important thing for the man pages. So looking up commands um, in your exam is probably not too helpful because you don't really need a lot of things. But one thing which gets a lot of people, which you'll see in Comp 1511 later in the term, is this thing called Malloc. And a lot of people don't really remember how Malloc works. And if you are in a pinch, you can't remember, you've got a mental blank, you can use this man pages as well to look at the documentation for that. And that might just save you. So yeah. So there's been a really good point in chat that you don't always have to specify the page. So the difference here is that for man malloc, there is not, if I just type man malloc, it doesn't matter. We get this C documentation already. But if I type printf, then I get this documentation for something completely different. And that's because printf is actually a shell command as well. So it's a function in C, but it's also a shell command. And that might be a bit confusing. We're not going to talk about what the shell command does, although it operates in a similar sort of fashion. But the reason we had to specify the number, as pointed out by this excellent comment in chat, is that there's multiple things. So there's a C function called printf, and there's also a shell command called printf. Just as a bit of fun, you might be wondering, can we look at the documentation for man? Yeah, we can. We can look at the documentation for man. And this is actually really quite helpful because it tells you the sections. So this is what all of the numbers mean. So when we said 3 before, this means the C library functions. So that's why we said 3 if we wanted to look at the printf function. So an excellent question in chat is, how do you know when to use a particular page number? This is something that you'll probably learn later on. Most of the time, a C function and a shell function do not coincide. So there's not usually a conflict here. Printf is I guess, not a great example in that there is a conflict here. But for most things, like when we saw malloc before, there's no shell command called malloc. Like if I try to run malloc, it says commands not found. Like there's nothing that we can do. But so we don't have to specify the number. So you can see that from before, we got the same output when we specified the page number or not. By default, it is man 1. Yeah, I think it is 1 by default, which is why it defaulted to the shell. So yeah. We have a question, what does man-k do? Yeah, this is another really helpful one. So let's say that I have the name of a command, but I don't know which one. So let's say I don't remember which page has the C function in it and which function has the shell function in it. I can use this -k printf thing, and this will show me all of the commands that have, well, yeah, this is really quite, maybe I should pipe this through less. It's already in less. All right. Can I go to the start? Yeah, okay. So it's a whole bunch of mess here. But if we focus on at the end here, what this -k has done is it's gone through and looked at every man page in every chapter, and it's showed me every single one that matched the search string printf. So everything that either contains the phrase printf in the title or the description, it's shown me here. So this is really helpful if you want to find the name of a command. So let's say I want to find this C function called fgetS, but I don't know where it is. So if I don't know which page to look at, if I do that, it's shown me which one it is. So this this parentheses notation we've got here, this bracket 3, the number inside this is the page. So from this, we can tell that if I wanted to look at the documentation for fgetS, I should do man3 fgetS, and there's the page. So man-k is basically your last ditch Hail Mary. I don't know which page to look for. I just know which one I want to see. Yeah, so if you get really desperate, that's something that you can use. But for the Comp 1511 people, this is probably not too helpful. And this is probably more towards the people who are doing Comp 2041 or Comp 1521, especially Comp 1521, because there's quite a lot of things to remember in those courses. And someone in chat has pointed out that he had to use this in his 1521 exam. So yeah. Doing Comp 3231 and you don't even know man-k. Wow, yeah, it's another very very useful thing to know for that course as well. Probably more useful than even 1521. So as we saw, the output of man is basically less. So you can use the key bindings we had before to navigate, jump to from. One thing which I will show off, something which I didn't cover, something that's very helpful, is let's say I don't want to bother scrolling through all of this and I want to find the return value of printf. So I want to see what this function returns. I can type / and then something I want to search for and then press enter and it'll bring you to basically the relevant part of the input. So let's just do and. If I search for and, it's going to highlight all of the occurrences of and in this file. So that's another thing which is quite helpful if you want to search for something. So let's say return. Okay, never mind. But you saw from before. Is there a search for the file system? So there is. Yeah, so it's a control F equivalent for the man pages. For the file system, it's something called find, but find is quite hard to use. So this is something you could probably use your man pages for. So you could have a read of the find man pages and see if you can figure out what it does. So, but I'll leave that as an exercise to you. So I know no one likes homework with these workshops, but if you want to play around and you want to see how to do that, then look at the man page for the find command. So with man, it's really quite helpful. So we're officially in overtime now. I spent a whole lot of time on that because I felt like it was really important, and I hope you can all see why it was so important, because it's basically a cheat sheet. But yeah, so that's man. Very helpful. Very important to know. Quite a few flags. All right, see ya. Okay, I think I know who that is now. Never mind. All right, so we'll move on. So now we'll talk about history. So the shell logs every command you type. So everything I've been typing so far in this sort of session has been logged to a file. And if I want to view the command history, view the things I've done, I can type the command history. And that shows me everything I've run. So everything I've run is here, and it shows it in order. So this is great if I want to look at what I've done. Maybe if I want to do something, maybe I want to run this again. So I can type less text file 1.txt. Ah, nice. I can do that now. But as I'm going to cover now, this is really not the best way to do it. So if you want to run something, you don't have to look through your history, then copy and then paste it. You don't have to do that. You can cycle through your last commands, and you can do that using the up, down arrow keys. So you may have seen me doing this already, but now I'm going to show you how to do it. So let's say I want to cycle through my last run command. Let's say I want to type that less command again. Well, I'm not a sucker, so I don't want to type this out again. What I can do is just press up arrow. It's the last command I run. It's already there. Pre-fills it for me. I just have to press one thing. And now we've got it. We can cycle further back than that. So let's say we want to look at the man pages for man again. So we can scroll all the way back to that. And here we are again. So now we're at man. So this is really helpful if you want to run commands over and over again. So let's say if you've got, I don't know, some set compulsion to run pwd over and over again. Well, you can save yourself 2 keystrokes each time by just pressing the up arrow and just keep doing that rather than having to type pwd. But recompiling, that's a really, really good way to use it. So if you don't want to type in dcc-o or whatever you might type, then the arrow going up is a really good way to do that. Saves you a lot of time. So that's something you should definitely be aware of. And it goes without saying that if you're scrolling through your history and you want to go forward again, like say, oh, sorry, I want to do man-k print off again, I can use the down arrow and that'll cycle me back through history. Or maybe I want to jump all the way back to a fresh prompt. I can just press down. Compile and run, compile and run. Yeah, that's a good workflow. One thing to note is if I'm already typing a command, then if I press up arrow, it's going to get rid of everything I've typed. Oh, actually it didn't, so it saved it, but yeah. In general, you probably don't want to be pressing up arrow while you're in the middle of writing a command, because that sort of defeats the purpose. But yes, cycling through history is probably the better way to do it. But there's one last way to do it. So let's say that your command, sorry, hold on. We've got a question. Does there happen to be a flag or something for DCC that runs after compilation? No. So you always have to compile first and then run the program. Although you can do it in one command, this is an extra. Let's suppose you had DCC here and you've run this command. If compilation was successful and you immediately want to run whatever program it is, so let's say the name was program, you can use this and thing here. So I'm not going to go too much into detail with this because, as is the moral of the story from this whole talk, basically, this is something that gets further into what I want to talk about today. But to explain what this does, this and is only going to run the thing on the right-hand side if this first thing succeeded. So if you had some sort of compile error, it's not going to try to run the program. But if compilation succeeded and there was no problems, it's going to immediately run the program for you. Can you string more than 2 of those together? Yeah, exactly. So I can't think of another command which I might want to run here. I don't know. Let's say I wanted to cat the program source after I'm done writing it as well for some sick reason. I can do that as well. So if the running of the command succeeded okay, then this will then show the command after as well. But it'll only do that if the running is successful. But yeah, so this is a sort of advanced shell feature, not one which I intended to cover, but just something for your information. You can use and to string commands together. But you can read more into that later on if you want. For our own programs, does it need to return of 0 to be successful? Yeah, it does. So anything other than a return of 0 will be treated as some sort of error. So your main function in your C program would have to return 0 in order for that to be successful. Yeah, good point though. But that's something you'll probably cover more in Comp 1511 later on. So the third way for looking at things that you've run is what's called a recursive search or a backward search. And this is really good if you want to look at something that's like really far back. Like my command history is not very long here, but you can see it takes a couple of seconds. But if I wanted to run something at the very beginning, there is a better way to do it. So I don't know, let's have a look at our history. What's our first command? Let's say we wanted to, okay, let's cd. And let's say we wanted to run this first command, but we don't want to type it again. We can press Control R. So that was Control R, and that'll bring up this reverse I search thing. And then we can just start progressively typing what we want. So it didn't take long. I typed cd and then a space, and it's already found the command that I want to look for. And now, if I press enter, I've done it. So that's already done the command. So this is great if you have a really, really long shell like history. I mentioned earlier that I don't use bash. The reason my history is so short is because I don't use bash. But if I were doing this on my main shell, which I use, my history file is going to be thousands and thousands of lines. And you can just imagine how long it would take to scroll through all of that, holding down arrows. So that's really helpful. I'll wind back a bit and answer this question. What is the guarantee to work method of installing software via bash on Ubuntu? That's a really complex topic, really not the kind of thing that I want to talk about here. I would recommend you Google that, because yeah, that's getting quite ahead of the content of this talk, and we're already going over time. How do you clear your search history? Yeah, so if we have a look, we poke around in my home directory and we look for something. Let's have a look at the file that shows everything I've got. So this one here, which I've highlighted, this .zsh_history file that I've got in my home directory. This is where, when I'm using ZSH, all of my commands go. So this is a log of all of my commands when I'm using ZSH. If I want to clear my history, I just remove the file. So I want to keep this history because it gives me a nice bit of completion. But if I wanted to remove all of my history, I just remove the file. So I would do rm.zsh history. And there should be something similar for bash as well. So you should type rm.bash_history if you wanted to remove the bash history. So that's how you do that. That's how you clear your history, is you delete the history file. Because really what all of these commands are doing is basically all of your commands get whacked into a file. They just look at things in the file. So that's really all it is. You've Googled it 100 times. Yeah. Maybe after this talk, I'll give you a little bit of guidance, but I won't bother talking about it now. If you want to, one thing I forgot to mention, if you're in the middle of a recursive search, let's say I wanted to type this command, but I've decided, never mind, I don't want to do this. If I press Control-C, it stops the search. So now I'm just back to a normal command line. So if I want to abort a search, I just press Control-C. So I think the last thing I'll talk about for the main part of this talk is the shortcuts for writing commands. So these are key bindings which we can use to help us write commands efficiently. So the shell offers quite a few of these, and most of them have to do with moving about the current line that you're typing. So you may have seen me, if I'm typing stuff, you might have seen me immediately jump to the start of a line or the back of the line, for example. I can't do this in just a one arrow press, so I must be doing something. What I'm doing is I'm using commands, command shortcuts, which the shell provides me. These are called the read line bindings. The bindings that the shell uses are really a subset of these read line bindings. In the document file, which you will get once you fill out the feedback form, I have a link to that in there. But you can also just search like bash key bindings, and it'll show you the list of them. And there's quite a few of them, and I'll just show off a couple of them. Whoops, didn't mean to do that. So one thing as well, one of the more important things is that I've been doing in this talk is if I want to complete something, so let's say I have text_file. Well, rather than typing all of this, I can press, no, actually, this is a bad example because bash is not great with this. So let's find a unique one. Let's try dad songs. So if I want to type dad songs, I can type dads. And this is reasonably unambiguous now. If I just press tab, it's auto-completed it to dad songs for me. So if I just type a little bit of the start, enough for it to disambiguate between possible other entries in the current directory, if I just then press tab, it's smart enough to know which one I'm talking about. So to do that again, if I just type dad, I just press tab. That completes it after I've just written dads. So that saves us a bit of time. That's very useful. So this is probably the most useful thing that you'll learn from these bindings. But there are a couple of others. So the ones I was showing off earlier, I'm jumping to and from the line. These are Control A and Control E respectively. So if I want to go to the start of the line, I press Control A. That's just what I press, Control A. And if I want to jump to the end, I press Control E. So just press Control E there. So that's really helpful if you just want to jump around. If you want to move ahead by words, so let me type in a bunch of words, doesn't really have to mean anything. What? Okay, maybe I should try not enough words, like that. Yeah. So if I want to move around words rather than having to backspace through them, so rather than having to do all of this, I can press Command, Control, if you're on Linux, plus arrow. Oh, this is different on Macs, rats. Okay, I don't know what the way to go back on Mac is, but if you're on a Linux machine, you'll have to take it by my word. If you press Control and then the arrow keys, it'll move you back by words instead of just by characters. So you can imagine if I press Command and then arrow, I'll end up here. If I press Command and left arrow again, I'll end up here. So that's really helpful for moving about. Unfortunately, on Mac OS, it's a little different. I don't quite know what the shortcut is on Mac, but I leave that as an exercise. If you do have a Mac, you can just Google it. You'll probably won't remember all of these bindings off the slides, so just have a look at a cheat sheet anyways. The last section is going to be deleting. So this is really helpful if I want to delete words, and I know this will work on a Mac. So let's say I type this word. If I don't know any better, I'll have to backspace and hold down backspace while I'm doing this. But if I just want to delete this word, if I press Command W, it deletes the word that comes behind the cursor. So you can see that if I type here, the word behind the cursor is this one. So I guess I'll add more words so that I can show what it does. This current word here, this is the one that's before my cursor. If I press Command W now, it just deletes that word. And if I press Command W again, it deletes the other word. And you can press Alt D if you want to delete the word that's in the front. So if I teleport to the front and I press Alt D, hello, Command D. Okay, this is another Mac OS thing. It'll work if you're on Linux, basically. If you press Alt D, then if I was here, it would get rid of the word. So if I was at the front and I pressed Alt D, it'd get rid of the word. But my Mac is a little bit funny, so unfortunately this does not work. It's really unfortunate that this isn't being cooperative for this talk. These ones here are going to work, the ones I skipped over. So that was deleting words. I figured I'd cover that before I covered lines. So instead of maybe deleting a word, let's say I wanted to delete a whole line. If I press Command K, when I go to the start, it'll delete everything from there. So let me give myself a bit of text and let me move back. If I press Command K now, it'll delete everything after my cursor position. And if I do the other way, if I press Control U now, that deletes everything before. So all of this text here, this is everything that's before. If I press Command U, it all gets deleted. So in practice, if you want to clear a whole line, probably what you'll want to do is use one of the start and end commands to jump to and from, and then use the appropriate one. So I'm at the start now, I'd press Command K in order to clear it. So that's if you want to clear lines. So that's really helpful, saves you backspacing. One last shortcut, which I want to show off, is Control L. So Control L is one which clears your screen. So you can type the command clear and it'll clear it for you. But let's say I do a whole bunch of stuff here. If I press Control L, it just does it for me. So that's a lot quicker than pressing just clear. So yeah, I think that's it for the commands. So does anybody have any questions about these shortcuts for navigating the terminal or all of these tools which I've shown off? Okay, I'm going to take the silence as no. All right. So these last two sections are quite complicated and probably going to take a while to get through because I would probably want to go through these really slowly so that you understood them. So as a show of hands, who wants to go through that? Because I'm happy to do it if people want, but I'm just advising you that it probably might take a while. So if you've got something to go to, yeah, this might cut into it. Do it. Let's go. All right. So everything which I've covered so far is pretty basic stuff. Now we're getting into more advanced territory, and this is really where we start to see the magic of Unix. Because what we've seen so far, I mean, it's cool, but none of it is technically like a hallmark trademark of Unix. These two features, which I'm going to show off, are. So this is really what made Unix special. So the first of these, actually, before I do this, because I'm going to do this as like an addendum to the talk, I'm going to skip ahead and I'm going to cover all of this because I don't imagine that everyone will want to sit through all of this. So we're going to assume that we're going to wrap up here, but I'll continue going after this. So if you don't want to sit around for the more advanced stuff, but you do kind of want to see more of this after today, I would recommend you take the course Comp 2041. So that's Software Construction Techniques and Tools. So that really does everything we've done here plus more. Very helpful course. So yeah, covers everything we go into today, but it also teaches some other stuff. So how to write shell scripts. So that was mentioned in the chat earlier. Yeah, so if you want to learn all of this stuff, if you found this really interesting, definitely look at doing that course. Runs term 1 now. So unfortunately, you used to be able to do it in first year because it used to run in term 2, but I think they've changed it to term 1 this year. So you're going to have to wait, unfortunately. But if you do want more of this, that's, I think, the course to take. Fill out the feedback form. So I'll come back to this at the end for those of us who stick around, but everyone who doesn't, the feedback form is in the slides. I'd really appreciate it if you went through and took the time to do this. As I've also said earlier, if you do complete it, you get a command list with everything that I've hopefully showed off today. So that should be like a good cheat sheet if you want that. So yeah, there is some reward for filling this out, but please fill this out. Really helps us a lot. Yeah, okay. I don't know that we'll have enough time for Q&A. So this is our Q&A. So with all of the admin stuff and to say goodbye to everyone who isn't going to stick around for this last part, hopefully you enjoyed. Let's get into the tail end of this talk. So I don't know that anyone's left, which is good. You're all brave. You're all brave sitting through this after we're running over time. So the first really important thing which we're going to talk about is redirection. So redirection is a bit of a complex one, and it's complex because beforehand we have to talk about these things called file streams. So on your Unix machine, there are three main file streams that it uses to read or write data that you use when you're running programs. So if you're going to provide input to a program, that comes in from what is called the stdin stream, the standard input stream. So if you give user input to a program using scanf or something, then it's going to read from this stdin stream, this standard input stream. All normal output of commands will go to what's called the stdout stream. So if you print something using printf in your C program, it's going to go to stdout, which is the standard output stream. So it's where all of your standard output goes. There's one more special stream called stderr, which is for error output. So sometimes a program can elect to write this output to an error stream, and this sort of separates it from the stdout stream. And we'll see why this is important later on, but it's enough for now to know that there is technically a separate stream called stderr for error outputs, but where it gets a little bit confusing is that it's up to the person who writes the program whether they want to write error output to stderr or stdout. So it's a conscious choice they have to make. If I want to print an error message, then it's up to the programmer to decide whether I want to give it to the output stream or the error stream, which is where it really gets a bit confusing, which is why these topics are a little bit more advanced. So I'm going to pause now because I can see a question, and I'll also leave you guys some time to mull over what I've said. I don't have the slide yet, so where can I do the feedback? Hold on. Let me grab it for you and I'll send it in my other thing. So here is the feedback form. So if you want to keep that open or you want to fill that out now, I'd really appreciate that. But back to file streams. Are there any questions about file streams? So that's the stdio.h. Yes. So stdio.h is a header file for C, and the functions that you get with it, so the printf function you're probably most familiar with, those all write to stdout. And they take input from stdin. So whenever you use scanf, like I said, that's stdin. Whenever you're using printf, that's stdout. But I think the one confusing part here is that error output doesn't necessarily need to go in stdout or stderr. Like there's nothing stopping someone from writing normal output to stderr or just writing error output to stdout, which is really, it's a point of pain for a lot of programmers, because there's no one consistent notion of which stream we should use. There's customary things that we should do, but there's nothing stopping someone from just doing this, which is a bit confusing. So now with file streams out of the way, we can talk about what actual redirection is. Like when you print something as a red error in Unity to make yourself pay attention to it, yeah. So that may not necessarily be on stdout or stderr. It's up to the programmer, up to the software, which is where it gets really confusing. So the whole point of covering this is now we want to redirect the output of a command. So previously when we typed something like ls, it just prints out to our terminal. It's printing out to stdout. But what if I wanted to save the output for some reason to a file? Well, we can do that. We don't have to manually go and copy this, open a file, paste it in, all of that. We can let the shell do this for us using redirection. So we'll start with redirecting input first. So if we want to make a command read its input from a specific file, instead of just taking input on the standard stdin input stream, we can use this less than operator in conjunction with that file's path. So before we jump in, we'll just look at a concrete skeleton. So we have a command, flags, args, and this is the part that we do in order to redirect it. So this is the command we want to capture the output of. And this little part in orange here is really telling us we want to feed input instead of on the command line from this file. So I'll show you an example of that. This repeat.c thing, which I showed earlier, this is just a C program. You probably don't know what it does. Basically, it works like echo. So if we did hello world, this program, run repeat, hello world, it's going to do pretty much the same thing. Although the functionality of this repeat is more similar to cat, because echo will only take one phrase and then stop. I can do whatever I want here. I can keep saying until I kill the program. So this is something which I prepared earlier. It doesn't really matter what all of this code does. The point is we have some command. I had to type in all of the input when I wanted to do it there. But let's say I wanted to feed it the output of one of these text files. So let's say I wanted to give it the output of what's in text file 2. Okay, it's shorter. This is a lot nicer. So let's say I want to feed it this. What I'm going to do is I'll use the less than symbol, and then I'll specify that file. And you can see it worked. So without me having to manually enter these lines, it's automatically done it. So what this has done is repeat on its own by default will read from that stood-in standard input stream. What I've done is I've hijacked that and changed it to a file. So instead, it's reading from a file instead. So this is a very useful feature if you want to specify a complex set of inputs to a command in a file. Say you've got a whole bunch of commands you want to run in sequence, but you don't want to run them yourself manually. We can just put them in a file and then redirect the input to that file. Yeah, we can just redirect that, and that does it for us. So we can imagine that this is perhaps maybe a different program that takes in a bunch of instructions. What this is going to do, if we put in all of the instructions in a file and then we redirect it like this, it's just going to feed them in for us manually. So I assume greater than exists to write a file. Yeah, you're exactly right. And that's actually the next slide. So if we want to redirect the output of a command, then we use pretty much the same, but we use a greater than sign. So I don't know that I need to explain too much other than you just swap this for that, but we'll show an example. All right, let's say I do a list of all of this, and for some reason, I want to save this to a file. Well, the dumb way to do it is to copy all of this text, and then, whoa, this is, oh, okay. Yeah, there we go. Whoops. The shell's a bit weird like that. Okay, we'll restart. So we've got all of the output, and let's say I want to save this to a file. Instead of copying it, what I can do is just specify a file. Let's say lsoutput.txt, lsout.txt. You can see that it printed nothing there. And now, if we look at our lsout file, it contains everything from that command. So there's an excellent question in the chat here. Yeah, this will be the next slide. So but to answer your question, by default, if the input file already exists and you use a single greater than sign, it's going to overwrite. So we'll talk about how to append next, but we'll focus on this single command for now. You can see why this is helpful. So maybe the output of ls is pretty novel, but if we're doing some testing of a program and we want to look through that output without having to run it every time or deal with scrolling through the terminal, we want to open it in an editor maybe, something like gedit, this command is really helpful for that. And hopefully you can appreciate that. So yeah, it's a very useful feature for inspecting or saving the output of a command. So we can save it to a file and then just do something with that file later on. rather than having to rerun the command. Because you can imagine if this operation is also really expensive and we're not going to run it again, but it might take a couple of hours, well, maybe we want to use what it provides multiple times, but we only want to run the command once. Well, if we just set it to write to a file, then we get further accesses to it for free, basically. So you don't have to rerun the command. This is why it's really helpful. So if we want to make the command append or add lines to the file instead of overwriting it, we just add one more, we just add one more greater than sign. So what this is going to do is, if we then have a look at the file, it's appended it twice. So this would actually be a great time to use less. It's appended it twice. Can you redirect the output of one program to the input of another directly? Yes, 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 you can. And we will see this later on, although probably the best way to do it is something I'll cover after this. You don't want to use the less than and greater than redirection symbols for that. There's a much neater way to do it. But you can see here that we have indeed appended to the file now. We've appended another copy of ls to the output. So yeah, to summarize, this less than sign redirects input, this redirects output, this redirects output and appends to the file. So yeah, really, really helpful. And this is getting to be one of the reasons why Unix is so special. So that is a relatively complicated topic. So I'm going to pause here before we move to the next one. Is there any question with that? Any question with any of this? I hope I explained it well. I think the most confusing part is this whole thing about file streams, but all of this should be relatively self-explanatory, I feel, after you've got that. Okay, thanks. So with that, we will move to the last feature I want to talk about. And really, this is the crown jewel of Unix. This is really why it's so special. So if you remember before, we talked about wanting to have programs that worked together. So we have all of these programs like ls. Like ls is really good at showing the contents of a directory. It's really good at that. It doesn't do anything else. It serves its purpose. It's really good. But maybe what we want to do is something a little bit different. So I'm going to pull something up on the side because I have a really nice example I want to use here, but I don't remember it off the top of my head. Okay, we've got it now. So let's say that we want to do something a little more with ls, but we don't want to rewrite it. So we don't want to write our own copy of ls. We want to ideally use some existing programs on our machine and glue them together, combine them, such that we get what we want. So this is that whole thing of working together. And the way that Unix does this is this thing called pipes. And really the title of this slide says it all. How we compose commands is we use things called pipes. So let's start with a couple of basics of pipes. So as Blake has excellently said, one common thing we want to do is feed the output of one command as direct input to another command. So we can imagine maybe we want to take the output of ls and immediately put it into something else. So maybe we had some function which or program which turns it into all capitals. So it replaces all lowercase letters with capital letters. Well, at the moment, the only way we can really do that, well, we have two ways. We can either manually enter the ls input ourselves, don't want to do that, or we could we could capture the output of ls to a file, and then we could run that command. And we could use our redirection trick to redirect the output of the ls command to a file, and then redirect the input of the command we want to run after to take input from that file, if that makes any sense. So those are two ways to do it, but the preferred way to do it is using these pipes. So pipe is that, that pipe character in chat, this orange one here. And it's really syntactic sugar for capturing the output of a file and then immediately feeding it as input. And I hope you can understand why it's a pipe, right? Because you can imagine we've got a pipe here. We take input into this. So this is the output of our one command. It goes in and it goes down the pipe as input to the other commands. So that's why it's called a pipe, because it is just like a physical pipe, just on your computer. So the usual form when we're using pipes is this here. So we'll run the first command. The first command is the thing that we want to generate our output. And then the second command is the thing that we want to run with that output. So here, to show you an example, I think it's best to do an example. Let's say I want to be a little bit tricky, and I've looked at a head and tail, and I've decided what would be really nice is if I could look at, say, the last 5 lines of the first 10 lines of the file. So in effect, the 5th, 6th, 7th, well, actually, I got the indexing wrong there. It should be the 6th, 7th, 8th, 9th, and 10th lines. So head and tail by default don't work like that. They work from the start or the beginning, but we can use pipes in order to do this. And you might imagine how we could do this. So let's grab the first 10 lines in our text file here, and we're going to treat that as our output. Now we're going to use our super simple example in this case, but super complex in terms of the idea pipe, to feed that to tail -5. So this first part here is going to give us the first 10 lines. And then the tail -5 here, instead of using all of the lines in the file, it's just going to use what head gave us. So it's just going to give us the first 10 lines. And then when we run this, yeah. So this isn't a really good example of a file because we have, like, I don't know, if we look at the file, it's quite a lot of different stuff. So let me perhaps create a new file. Let's say 1, 2, 3, 4, yeah. Okay, so I've just created a new file. Don't worry about the magic I just did. If we now use our new file instead, file, then that should make more sense. So we've taken the 5th, 6th, 7th, 8th, 9th, and 10th lines of the file. So this is a really simple example, as you can see. And what's really important to note here is we didn't have to write anything. We just had to think a little bit about how we can glue these programs together using a pipe. So as you can probably imagine, this is really, really quite a useful thing. So from this, we can build up really complicated software using these little simple things like this head and these tail commands. They do one thing really well, but when we combine them, we can do something else really well. We can look at the bottom line of the bottom 5 lines of the top 10 lines. So that's a contrived example. I don't know that many people would want to do that exactly, but it does show off the point I'm trying to make here. And I assume, again, you can string together more as A, B, and C. Yep, that's the next slides. So there's no limit to how many times we can use this pipe operator. So we can keep extending our pipeline as much as we want. So, if we wanted to, we can use this rev thing here. This rev command basically reverses whatever it's given. So for some, oh, actually, this is not a good example. How about I use the old, this will do for this one. So we've got a different file here. We've grabbed the bottom 5 lines as before, but now, I don't know, let's reverse all of the lines. There we go. We've done it. We've extended our pipeline by adding another pipe, and we filtered the output here to this rev. So basically now, all of the output of this particular separate pipeline is now fed as input to this rev command. This is really powerful, and we can just keep going. We can keep on going. Are 10 pipelines 10 different processes? Yes, I think so. Possibly, but I'm not sure. I think they may be, because the way the shell works is every time it runs a command, it runs it in a separate process. So when it uses head here, it uses this as a separate process. I'm not entirely sure. What it could possibly do is once this process is finished, it could possibly replace the process with the new one, because we're done with this now. We don't really care. So we could maybe in theory replace it, but I'm not quite sure whether Linux does this by default. But yes, you can create a lot of complex programs just using pipelines without needing to implement any part. Yeah, Kai can check and he can report back. So the example I wanted to give, this one's quite long. This example is going to, I'm going to motivate this. We have a whole bunch of like these programs that end with .cs, .hs, .js. These are all the file extensions, right? Let's say I wanted to look at all of the file extensions in my directory, and I want to know how many of each file extension there are. So I can build a pipeline for this. So first, we'll start with ls. And now we'll do some stuff that you probably won't understand, but have good faith that this does work. If you want to, this is a teaser for Comp 204, and if you want to know what I'm doing right now, you should do that course. Yes. Yep. Yeah. So after I type in that absolute mammoth of a command, maybe I should zoom out a little bit more. After I type in this absolute mammoth of a command, you can see I've got what I want. So we have, let's check this. We have two C programs. So this repeat.c and this repeat backup.c. We've got two of those, and all of the other ones are listed, and we've got 7 text files. So don't really try to worry about what's going on here. This is way too advanced for what happened here, but I'm just using it to show a point that you can construct really complicated pipelines to perform a simple task without having to write any code yourself. So you just have to think about how you can glue these together. Is it normal that it replaces like that on the same line? I don't think so. I think probably what's happening here is I'm zoomed in and my line is quite small. Yeah. Unfortunately, I don't really, unless I try to zoom out a little bit. Yeah, try to write it now. Yeah, but now I feel like the text might be getting a little bit too small. So well, maybe I could just do this. Yeah. Unfortunately, there is a bit of overflow, but this shouldn't normally happen. How do pipelines work with commands that take multiple inputs? Multiple inputs. So multiple inputs are usually done or modeled as a sequence of inputs. So if our command takes 3 numbers, for example, usually that's modeled like by saying that we have some file, we read 1, and we expect there's a 2, and then we expect there's a 3. So for commands with multiple input, yeah. Although if you're talking about something like cat that takes multiple commands, in the pipeline, you can only have one output. So when you pipe something, it's assumed that all of the output you're giving to it, a single output, is given to it then. So there's a sort of a limitation. If you have something that expects multiple complicated types of input, then unfortunately doesn't really work. To answer Kai's question, the command I'm using to zoom in and zoom out, this is going to differ per terminal, but for the one I'm using, I press Command or Control if you're on Linux, plus and minus. So plus makes it bigger, minus makes it smaller. Because I'm on a Mac, I'm pressing the Command key here, but for Linux machines, you don't have a Command key, so you would use Control instead. So yeah, now the text is real big. Yeah, so that's another sort of little thing. Yeah. So pipelines, yeah, this problem might not make complete sense to you. They are quite a complicated topic, but pipes are without question the most useful feature of the Unix shell. Because what we can do is we can construct really simple programs. We can make programs work together, really small programs that do one thing. They can all come together to build additional functionality without having to write all of these separate programs. So knowing how to use these pipes is a very, very good skill to have. It's one you will develop in Comp 204 if you take that course. You'll do quite a lot of piping. Okay, I think we're finally at the end. So we're 50 minutes over time, but I think we're at the end. So only one course on the topic. Yeah, so 204 is the only course I know of that explicitly teaches pipes. But then again, 204 does it justice. 1521, it covers this thing called pipes, but it's not the same really. So the kind of pipes you talk about when you talk about them in 1521, they're different to the kind of pipe we're doing here. So they're not pipes in the sense of these pipes. But certainly there is something in Comp 1521 that is called pipes. I think the pipes that you're probably thinking of from Comp 1521 are more like this idea of redirecting output and everything like that. So you can create pipes using C, but it's a little bit clunky. Yeah, I don't know. You do something like that, but it's not really the same as the pipelining that I'm showing here. But yeah, I think that's it. I don't have any more content to cover. So I think I'll just remind you, I'll go over everything with the administration again. So Comp 2041, that's the course you'll want to do if you really liked this sort of thing. You can probably also pick up a lot of this stuff through your own experimentation. So as you use the shell more and more, you'll probably learn new things. But yeah, if you just want to do a course on this, then Comp 204 is definitely that course. And it covers some more stuff as well, like shell scripting, which is also a really cool thing to know. Really good, really useful thing. Yeah, okay. I think that's it. So I'm going to stop the recording now. So for all those people who are watching the recording, bye.